Preface. This book is about programming for data parallelism using C++. If you are new to parallel programming, that is okay. If you have never heard of SYCL or the DPC++ compiler, that is also okay. SYCL is an industry-driven Chronos standard adding data parallelism to C++ for heterogeneous systems. DPC++ is an open-source compiler project that is based on SYCL, a few extensions, and broad heterogeneous support that includes GPU, CPU, and FPGA support. All examples in this book compile and work with DPC++ compilers. If you are a C programmer who is not well versed in C++, you are in good company. Several of the authors of this book happily admit that we picked up C++ by reading books that used C++ like this one. With a little patience, this book should be approachable by C programmers with a desire to write modern C++ programs. Continuing to evolve. When this book project began in 2019, our vision for fully supporting C++ with data parallelism required a number of extensions beyond the then current SYCL 1.2.1 standard. These extensions, supported by the DPC++ compiler, included support for Unified Shared Memory (USM) subgroups to complete a three-level hierarchy throughout SYCL, anonymous lambdas, and numerous programming simplifications. At the time that this book is being published, late 2020, a provisional SYCL 2020 specification is available for public comment. The provisional specification includes support for USM, subgroups, anonymous lambdas, and simplifications for coding, akin to C+++ 17 CTAD. This book teaches SYCL with extensions to approximate where SYCL will be in the future. These extensions are implemented in the DPC++ compiler project. While we expect changes to be small compared to the bulk of what this book teaches, there will be changes with SYCL as the community helps refine it. Important resources for updated information include the book GitHub and errata that can be found from the web page for this book, www.apress.com 9781484255735, as well as the ONIA PIDPC++ language reference, tinyurl.com/dpcbpref. The evolution of SYCL and DPC++ continues. Prospects for the future are discussed in the epilogue, after we have taken a journey together to learn how to use DPC++ to create programs for heterogeneous systems using SYCL. It is our hope that our book supports and helps grow the SYCL community, and helps promote data parallel programming in C++. Structure of this book. It is hard to leap in and explain everything at once. In fact, it is impossible as far as we know. Therefore, this book is a journey that takes us through what we need to know to be an effective programmer with data parallel C++. Chapter 1 lays the first foundation by covering core concepts that are either new or worth refreshing in our minds. Chapters 2 to 4 lay a foundation of understanding for data parallel programming C++. When we finish with reading chapters 1 to 4, we will have a solid foundation for data parallel programming in C++. Chapters 1 to 4 build on each other and are best read in order. Figure. Welcome to DPC++. 1. Foundation. Chapter 1 to 4, 1.1, Q, 1.2, Buffer, 1.3, USM 1.4, Accessor, 1.5, Kernel. 2. Details. Chapter 5 to 12, 2.1, Error Handling, 2.2, Scheduling, 2.3, Communication, 2.4, Vector, 2.5, Devices. 3. In Practice. Chapter 13 to 19, 3.1, Patterns, 3.2, Tips, 3.3, Libraries, 3.4, Atomics, 3.5, Memory Models, 3.6, GPS, 3.7, CPS, 3.8, FPGAs. 4. Future, Epilogue. Chapters 5 to 19 fill in important details by building on each other to some degree while being easy to jump between if desired. The book concludes with an epilogue that discusses likely and possible future directions for data parallel C++. We wish you the best as you learn to use SYCL and DPC++. James Reinders, Ben Ashbaum, James Broadman, Michael Kinsner, John Pennycook, Zinman Tien. October 2020.